so there was a request to also do a little tutorial on resource 1.5 on the Python installation. We will write most of our ROS code in Python 2. It's best practice not to mess with Ubuntu's Python installation, which is Python 2, and instead install our own. The package pyend will help us to manage what will be multiple Python versions. Installing pyend is easy in a terminal window. This command here, curl, and then it gets from pyend, and it pipes that to bash. So let's do that. I've got this opened in Ubuntu in a couple windows, so let's copy and paste that in. Takes a moment. Great. Now, this warning at the end suggests that we copy and paste these 3 lines and put them into our bashrc file. So I give instructions here for doing that as well. So those 3 lines are also provided here for you, but you can also copy them in your shell. And if you're in your home folder, great, but it's okay if you're not. You can use gedit or Sublime to edit your bashrc file. So it's always in the home folder, .bashrc. Great. We'll scroll to the bottom and we'll add a line, pasting those 3 lines in, and we'll save it, Control S, and close it. Okay, now we need to either open a new terminal or type in exec shell, the environment variable shell, which will also reload our bashrc file. So we need to do that after a lot of installations, and especially when we edit our bashrc file. So that should do it for us. And now we can use pyend to install things. So if you want to make sure pyend is installed, you can ask it which pyend. It'll tell you where it is. And if you would like to know which versions of Python are installed on your system, you can type in pyend versions. And right now, all we have is the system Python installed. We would also like to install 2.7.17, so we can do pyend install 2.7.17 and enter. Alright, so we're back. Paused it while we were installing. There is a warning that is going to come up, and as far as I can tell, it is a benign warning. I've looked into it. It seems like it's benign. So now that we have our Python 2.7.17 installed, let's do pyend versions again, and we see that 2.7.17 is installed. However, the system is still set to be the default version of Python used at any point or at any current directory. So we'll set the global default to 2.7.17 like that, and that should work. Now if we do pyend versions, we see that the global is set to 2.7.17, and if we did Python version, this is going to default to whatever version pyend has set for us for this directory, which is 2.7.17. If for some reason we wanted to have some, let's make a folder and set a local version. So make dir, let's call it dumb, cd into dumb. We could do pyend local system, which would have the current version, then is going to be whatever the system is installed. So if I do Python version, well, it looks like this system is also the same version of Python, so it doesn't matter that much. But we do want to work with the one we installed, the 2.7.17 that we installed. So we set it globally now, and that is the one that will be installed. So that's great. Get out of there. Okay. Then we want to install Jupyter Lab. So I like, just in general, Python code. We'll be making some Python code in just a text editor, but it's also nice to have, whenever you're working with Python, it's nice to be able to use Jupyter Lab as an IDE for that Python code. So it's something that I like. I wanted to show you guys. So pip install Jupyter Lab. It'll complain about Python 2. It's okay. We can continue to use Python 2. This shouldn't take too long. Pause it a moment. And it was really just a moment. Here we go. We are we now have Jupyter installed on the machine. So now we can do, in some directory, see, what do I have here? Let's say I want to develop some Jupyter or some Python code here in my home directory. I'll type in Jupyter Lab. It will launch this, and I can start up a notebook, a Python 2 notebook, or a console in Python 2, which will act like an interpreter in Python. I can do Python commands in there, or a terminal. So let's open a notebook just for fun, and let's do print hello world, shift enter, and it prints hello world. So that's sort of the hello world there. If we wanted to do this in a console, we could do that as well. So this acts a little bit like MATLAB's command window. We could do print hello world and shift enter again, and it will evaluate that in an interpreter interactive environment. So pretty nice. You can also pull up a regular terminal window here as well, inside Jupyter Lab, which is pretty cool. Sort of a matter of taste. If you want to do that, then that's great. This should have our bashrc file and have loaded it. So you see that pyend is there and everything. If we cat it, we just print it out. Yeah, I think I could even launch like gedit if I wanted to. Although there is also a text editor in here, so you can edit text files as well. There's a text editor, which is pretty nice. So instead of using gedit or Sublime Text, you could also use Jupyter. So we could directly create .py files here. So instead of in a notebook environment, we could do the same thing in a text document. So let's rename this to hello world. Instead of .text though, we want to change it to .py. Hello world.py. The shebang, I'll talk more about that later. But for now, we should be able to just print hello world here and save this Python file. I just hit Control S to save it. And then in our command window, we could type in Python hello world.py, and it would print out hello world. We could do the same thing in our terminal app as well. So open up a new tab. This hello world.py is here, so I could just execute Python hello world.py, and it would return hello world. So there are just a few options for you. At the end of the day, we're going to be making .py files. Notebook files are really nice because you can do things like if you hit M, you have the cell selected, and then enter, you can type in just markdown style things. So hello, this is markdown, and then you can say here some code. I might say like sudo. Well, I don't want to do that. I'll do echo hello world. And this is just typing in with those backticks some formatted code. I could do here's an equation and type in a LaTeX equation. So like x squared equals 8. And then when I hit Shift Enter on this markdown cell, it will actually render it nicely. So you can put in these nice markdown cells. You can also type in executable Python statements like print hello world, etc. It's a really powerful interface. I like it a lot. For those of you who have used Mathematica in the past, this notebook environment is great. So yeah, I recommend using it. You can export the notebook into these different forms. You can sort of publish it to LaTeX, Markdown, PDF, and there's also a way to convert your Python notebook into a .py file, like hello world.py. And in this class, we're going to need to have .py files to run ROS nodes with. So I'll show you an example of that later on, how to do that. So yeah, that's all I've got for you.